Hey guys, welcome back. I hope you had an opportunity to watch the how do we add and subtract radicals. When we were adding and subtracting, we needed the same number under the square root in order to perform the operation. But now that we are multiplying radicals, we don't. And that's one of the things that I love about multiplying radicals. The way that we multiply radicals is as follows. You take a number times a number. So we're going to do 2 times 3. That's 6. Then once we get here, we go 2 times the number in the front. If you remember from my last video, every square root has a 1 in front of it if there's no other number in front of it. Okay, so 2 times 1 is 2, and we're going to keep the square root of 5. A number cannot be multiplied, or it does not multiply with the number underneath the square root. Okay, so we did the first and we did the outer. Let's do the inner. 1 times 3 is 3. There's a plus sign. And then rad 3 goes with the person right next to it. Since there's nobody there, we just bring it along. 1 times 1 is 1. And the square root of 3 times the square root of 5. The great thing about multiplying radicals is that you just multiply the numbers on the inside. So if you remember my adding and subtracting video, the only way you could ever combine these is if they have the same number underneath. Now 5 is a prime, so this person is done. 3 is a prime, this person's done. And even though 15 is not a prime, no perfect number comes out of the square root of 15. So you're basically done. This is your answer. Let's try another one. Here we have first, that's 12. Outer, that's a positive 4 radical 6. Once again, the 4 cannot touch the 6. Think of this as inside, so it cannot go inside. So that's your first and that's your outer. Let's do our inner. Negative, that's a negative 1. Remember, if there's no number in front of it, put a 1 there. Negative 1 times a 3 is a negative 3, and there's a radical 7. Okay, you got to put the radical next to it. Then negative 1 times positive 1 is negative 1, and radical 7 times radical 6 is radical 42. You could multiply numbers underneath the radical together. This is fine, this is fine, this is fine. 6 is not a prime, but it can't be broken down where one of them is a perfect square. 42, I can't think of two numbers that can go into 42 where one of them is a perfect square. So I think we're safe there. So this is our final answer. Okay? Let's try it here. So if anyone has trouble imagining or envisioning this, you can say 5 needs to multiply the 4 minus 2 radical 2. And then you can take the plus 3 radical 3 and multiply it by the 4 minus 2 radical 2. So you can do first, outer, inner, last, like we did in the last two examples, or you could just take this person, multiply by the whole thing, and then this person and multiply by the whole thing. So let's see what happens here. That's 20. The number times the number, that's negative 10 rad 2. Let's do a number times a number. Positive 3 times 4 is positive 12. Now the radical 3 stuck to this 3, so you got to bring them along. And finally, let me change colors. 3 times negative 2 is negative 6. And then rad 3 times rad 2 is radical 6. Once again, none of these go together because in order to go together, you need the same number underneath the square root. So you're finally done with the problem. In our next example, we are going to multiply conjugates. Conjugates are two expressions that look exactly the same, but with opposite signs. And the great thing, well, I'm not going to give it away. I'm going to show you. 3 times 3, 9. 3 times negative radical 3 is negative 3 radical 3. This is a positive. Positive 3 times positive, there's a 1 there. And then positive 1 radical 3 times a negative 1 radical 3 is really a square root of 9. Remember, when you multiply radicals, you multiply the people inside. So a couple of things is going to happen here. This times this and this, they both have the same number underneath. So we can combine them. So if you owe me $3 and you have $3, then it's broken even. So we don't have that anymore. We have a minus. Do you guys know what the square root of 9 is? Sure, it's 3. So our final answer is actually 6. So I'm going to just say two quick things about this. Any square root times itself makes the square root disappear. You guys see it? Square root of 9 became a 3. So the square root just disappears when you multiply the same number. And here's why. We multiply the numbers on the inside, you get 9, and then the square root of 9 becomes 3. Okay, the second thing is conjugates always give us a solid integer. So when you multiply them, as long as these are real numbers, you'll always get 6, 5, 17, negative 30, and so on. Let's do it again. These are really, really important, so make sure you know how to do these. 5 times 5 is 25. 5 times positive radical 2 is positive 5 radical 2. Negative 5, keep this, make sure your signs are perfect, everyone. Negative 1 times 5 is negative 5 radical 2, right? And then negative 1 times positive 1 is negative, and radical 2 times radical 2 is radical 4. But radical 4 is 2. The insides disappear because you can put those together, and then radical 4 is 2. So this whole thing is 23. Last problem, 4 times 4 is 16. 4 times positive 3 is going to be positive 12 radical 2, because this has a radical 2. That's first and outer. Let's do inner. Negative 3 times 4 is negative 12 rad 2. And then negative 3 times positive 3 is negative 9. And rad 2 times rad 2 is just 2. So the insides disappear, and look what happens. 9 times 2 is 18, so you get negative 2. So that's how you multiply conjugates. Now I want to show you a quick way. You guys are going to thank me as soon as I show you this. If you ever want to multiply conjugates and it really, really fast, and it only works for conjugates, I always say square, square, square. Just square this number. What's 5 squared? Oh, there it is, 25. No matter what, bring down the negative, no matter what, even if it was positive first. There it is. What's 1 squared? 1. What's square root of 2 squared? 2. All you have to do is square, square, square. Let's try it here. Uh-oh. Sorry. Let's try it here. Square, square, square. Ready? 4 squared is 16. Always a minus no matter what. 3 squared is 9. Radical 2 squared is 2. 9 times 2 is 18. No matter what. People are probably saying, what about this person? It doesn't matter which one you do it to. You just have to do it to one of them. You get the answer. It's the same exact thing as first, outer, inner, last. Okay? So that's how we multiply conjugates, and that's how we multiply radicals. Come back for dividing radicals. Have a great day.